Good day, students. Welcome to our lesson for this week in pre-calculus. Today we're going to discuss the ellipse, solving for the standard form, finding the general form of the equation of the ellipse, as well as determining the coordinates of its parts. So now let's start. What is an ellipse? Ellipse is the set of all points on a plane whose distances from two fixed points in the plane is constant. So ellipse is one of the conic sections that we are having here in pre-calculus. The fixed points are called the foci, or the plural of focus, because we have two foci here. So take a look at the figure. So we have f sub 1 and f sub 2. Those are the two foci. The line through the foci is called the focal axis. The point on the focal axis between the foci is the center. So take note of that. Look at the figure. So the midpoint of the segment, which endpoints are the focus, the endpoint of it is the center of the ellipse. The points where the ellipse crosses its focal axis are called the vertices. So here, the longer axis is the major axis, and the shorter axis is the minor axis. Okay, so the midpoint of the major axis and minor axis is also the center. So if you're going to apply the midpoint formula given the coordinates of the vertices and the co-vertices, you're going to get, or you can get, the coordinate of the center. The line segment joining the two vertices is called the major axis. So take a look at that. And the line segment joining the two co-vertices is called the minor axis. The line segment through the center, perpendicular to the major axis and terminating at the ellipse, is called the minor axis. The endpoints are the co-vertices. The eccentricity of a curve tells us the amount of roundness of the curve. The eccentricity of circle is 0. That of the parabola is 1, while of the ellipse is between 0 and 1. So we can express it as 0, or the eccentricity between 0 and 1, where E is the eccentricity of the ellipse. A small eccentricity indicates that the ellipse tends toward being circular, whereas an eccentricity close to 1 indicates that the ellipse is elongated. So take a good look at our figure here. So this is how the ellipse looks like. Its parts, the vertices, the center, the co-vertices, the focus or the foci, the major axis and the minor axis. So the formula for C is equal to C square equals A square minus B square. So that's different from the Pythagorean theorem, okay? It's not the Pythagorean theorem. So C square is equal to A square minus B square. So the eccentricity is equal to C over A. And the length of the latus rectum is equal to 2B square over A. Take note of that. So we have cases here. The first one, horizontal ellipse with center at the origin or 0, 0. So look at the figure. The center is at 0, 0, or the coordinates of the center is 0, 0. The coordinates of the foci is positive or negative 0, or I'm sorry, positive or negative c, 0. C can be solved using the formula c squared equals a squared minus b squared. The coordinate of the vertices are positive a0 and negative a0. Look at that. The endpoints of the major axis are the coordinates of the vertices or the vertices. Then the co-vertices are the endpoints of the minor axis. The coordinates are 0 positive b and 0 negative b. So take note that A is greater than B because the major axis, the length of the major axis is 2A and the length of the minor axis is 2B. So the equation in standard form is x squared over a squared plus y squared over b squared equals 1. So that's the equation in the standard form of the horizontal ellipse with center at the origin. Take note that the major axis is in the x-axis and the minor axis is in the y-axis because the center is at 0, 0 or in the origin. Okay, so if you want to post this video, post it and then look at the figure, look at the coordinates of the center, foci, vertices, and co-vertices, the length of the major and minor axis. Okay. So now let's proceed to the next one. The horizontal ellipse with center HK. So the coordinates of the center is HK. The coordinates of the foci is H plus or minus C, K. Look at that. And look at our figure. Then again, c squared can be solved. You see the formula c squared equals a squared minus b squared. The coordinate of the vertices are h plus or minus a, k. Look at that. The vertices are the endpoints of the major axis, h minus a k and h plus a k. Then the coordinates of the co-vertices are h, k plus or minus b. So take a look at our figure. The endpoints of the minor axis is h, k plus b and h, k minus b, which are our co-vertices. And then remember that a is greater than b. So the major axis or the length of the major axis is 2a, the length of the minor axis is 2b, and the equation in the standard form is equal to or x minus h squared all over a squared plus y minus k squared all over b squared equals 1. So as you can see, there's h and k now. Take note that the major axis is parallel to the x-axis and the minor axis is parallel to the y-axis. So there will be cases that the major or the minor axis could be in the x and y axis respectively if h or k are 0. But if h and k are not both 0, definitely, if you graph the ellipse, the major axis will be parallel to the x-axis and the minor axis is parallel to the y-axis. Okay? Next is the vertical ellipse with center at the origin or 0, 0. So the center or the coordinates of the center is 0, 0. The coordinates of the foci are 0, positive and negative c. So look at our figure. So the ellipse is vertical. Those are the two focus C or the two foci 0 C and 0 negative C. So again, C can be solved using C squared equals A squared minus B squared formula. So the coordinates of the vertices are 0, positive or negative A. So look at our vertices. In the y-axis, 0A and A, 0A and 0 negative A. So the co-vertices or the coordinate of the co-vertices are positive or negative B, 0. So take a look at our figure. So the first co-vertex negative B0, the second co-vertex B0. Okay. So in this case, A is greater than B also. The major axis or the length of the major axis is 2A, the length of the minor axis is 2B, and the equation in standard form is x squared over b squared plus y squared minus a squared equals 1. So take a look of that. It's different from the horizontal ellipse with center 0, 0. So in this case, b squared is the denominator of x squared and a squared is the denominator of y squared. Again, the equation in standard form for vertical ellipse with center at the origin is x squared over b squared plus y squared over a squared equals 1. Remember that the major axis is in the y-axis and the minor axis is in the x-axis. Look at the figure. Okay? The minor axis is shorter than the major axis. Then next is the vertical ellipse with center HK. So the coordinate of the center is HK. The coordinates of the foci are H, K plus or minus C. So look at our two foci, H, K plus C and H, K minus C. So again, C squared is equal to A squared minus B squared. I hope you will remember that. Vertices, the coordinates are H, K plus or minus A. So look at our vertices in the figure. So H, K plus A and H, K minus A. Then the coordinate of the co-vertices are H plus or minus BK. Look at our co-vertices in the figure. H minus BK and H plus BK. And then A is also greater than B. The length of the major axis is 2A and the length of the minor axis is 2B. And the equation in the standard form of the vertical ellipse with center at HK is x minus h squared over b squared plus y minus k squared all over a squared equals 1. Take note that the major axis is sometimes parallel to the y-axis and the minor axis is sometimes parallel to the x-axis. Okay? But if the center is h and k are not, or there's no 0 in h and k, so definitely the major and the minor axis will be parallel to the y and the x-axis respectively. So now let us have an example. Number 1, find the standard form of the equation of the ellipse with the vertices negative 2, 1 and 4, 1 with eccentricity 2/3 or 2 over 3. So for the solution, we are not going to follow necessary steps because our steps could be different based on the given of the problem. So the important thing is that you know the given and you know what to do. So here we have the coordinates of the vertices and the eccentricity. So since that the center of the ellipse is the midpoint of the major axis between -2, 1 and 4, 1, therefore, we can use the midpoint formula to find the coordinates of the center. I have mentioned that before. The midpoint of the major axis or even the minor axis is the center. So let us make use of the midpoint formula. I hope you're already familiar with this. To get the value of x, let's have x sub m equals x sub 1 plus x sub 2 all over 2, which is -2 plus 4 all over 2 equals 2 over 2, so equals 1. And then for the y, sub m equals y sub 1 plus y sub 2 all over 2 equals 1 plus 1 all over 2 equals 2 over 2 equals 1. So our the coordinate of the center HK is equal to 1, 1. So we're not yet done. Remember that E is equal to C over A, the eccentricity. So given E is equal to 2/3, or the eccentricity is 2 over 3, then we can say that C is equal to 2 and A is equal to 3. So now we can find the value of B using C squared equals A squared minus B squared because we have now the values of A and C. So since we'll be looking for B, let us manipulate the formula. It will become B squared equals A squared minus C squared. Then substitute the values of A and C, which are 3 and 2 respectively. So we're going to have B squared equals 3 squared minus 2 squared. B squared equals 9 minus 4. B squared is equal to 5. So B is equal to square root of 5. So let's write it as it is. An irrational number. It's okay. And then graph the center and the vertices. So again, we use the GeoGebra graphing calculator. So I plot the coordinates or the points, the center and the vertices. So take a look at that. So it was given that these two vertices are the endpoints of the major axis. So meaning to say, the major axis is parallel to the x-axis. Since the major axis is parallel to the x-axis, therefore the ellipse is horizontal. Since the ellipse is horizontal, therefore use the equation x minus h squared all over a squared plus y minus k squared all over b squared equals 1. So since our hk is 1, 1, a is equal to 3, b is equal to square root of 5, and c is equal to 2, but we will not be using the value of c here, only the value of a and b. So let us substitute the hk and a and b in our formula. So we're going to have x minus 1 square all over 3 square plus y minus 1 square all over square root of 5 square equals 1. So the denominator will be 9 and 5 because the square root of 3 is 9, the square of square root of 5 is 5. So now we have x minus 1 square all over 9 plus y minus 1 square all over 5 equals 1, and that is the standard form of the equation of the ellipse. So we got it. So now for number 2, solve for the general form of the equation of the ellipse x minus 1 square all over 9 plus y minus 1 square all over 5 equals 1. This is actually the standard form of the equation of the ellipse from item number 1. And also find the following: coordinates of the foci, coordinates of the co-vertices, the length of the major axis, the length of the minor axis, and lastly, graph the ellipse. Okay, so here in number 2, we will be based from our obtained data or answers from number 1. Now, let's proceed. So since The standard form of the equation is x minus 1 square all over 9 plus y minus 1 square all over 5 equals 1. So since the LCD is, or the least common denominator is 45, so let us multiply both sides of the equation by 45. So 45 divided by 9 is 5 times x minus 1 square is 5 times x minus 1 square, and then since 45 divided by 5 is 9, so that's why it will become plus 9 times y minus y square equals 45, because 1 times 45 is 45. So now we have 5 times x minus 1 square plus 9 times y minus 1 square equals 45. So square those binomials inside. So now we're going to have 5 times x squared minus 2x plus 1 plus 9 times y squared minus 2y plus 1 equals 45. So just distribute 5 and 9. So we're going to get 5x squared minus 10x plus 5 plus 9y squared minus 18y plus 9 equals 45. Then 5x squared plus 9y squared minus 10x minus 18y plus 5 plus 9 minus 45 equals 0. So combine the like terms, write it in general form. So now we're going to have 5x squared plus 9y squared minus 10x minus 18y minus 31 equals 0. And this is the general form of the equation of the ellipse. But we're not yet done, because we still have to find the following. So solution answers for this. Let's find the coordinates of the foci, which is h plus or minus ck. The coordinates of the co-vertices, which are x or h, k plus or minus b. The length of the major axis, which is 2a, and the length of the minor axis, which is 2b. So we will be using this information that we have obtained earlier. The coordinate of the center is 1, 1. A is equal to 3, B is equal to square root of 5, and C is equal to 2. So by using the following, we can get the coordinates of the foci and the co-vertices. The coordinates of the foci will be 3, 1, and negative 1, 1. So just perform the necessary arithmetic. H plus C, so 1 plus 2 is 3, 1 minus H minus C, 1 minus 2 is negative 1, okay? Correct. Then coordinates of the co-vertices, so we have 1, 1 plus square root of 5, and 1, 1 minus square root of 5, okay? So we just wrote it this way. But if you want to convert it into decimal, that's also okay, but the result is an irrational number, so the decimal is an ending. Okay, so just write it this way. It's already acceptable. And then the length of major axis 2a, so this 2 is very easy to obtain. So 2a, just substitute a, 2 times 3, so it is equal to 6 units. The length of the major axis is 6 units. Then the length of the minor axis, 2b, is equal to 2 times square root of 5, so it is equal to 2 square root of 5 units. Okay? Then lastly, graph the ellipse. So I plotted the points, or the center, the two vertices, negative 2, 1 and 4, 1, based from the given, and then the obtained coordinates of the foci. So the first focus, negative 1, 1. The second focus, 3, 1. That's it. And then I have expressed 1 minus square root of 5 and 1 plus square root of 5 in decimal for me to graph or to plot the point. So as you can see, these two co-vertices are there. Okay. And then using the general form of the equation of the ellipse, this will be the graph of the ellipse. If you're going to use the standard form of the equation of the ellipse, you are going to get the same graph actually. So now we can conclude that we have obtained the correct answers. We have answered the problem. So this is the beauty of mathematics. When you done things correctly, you're going to arrive at the same answer. So be careful. Simple mistake can mess up your solution. And you're very fortunate because you can make use of this software such as GeoGebra graphing calculator and Symbolab graphing calculator in order for you to easily graph the conic sections. You can graph lines, circle, parabola, ellipse, hyperbola here. Just encode the equations correctly. For example number 3, find the standard form of the equation of the ellipse 9x squared plus 4y squared minus 5x. Minus 54x minus 16y plus 61 equals 0. Let me read it again. 9x squared plus 4y squared minus 54x minus 16y plus 61 equals 0. So here, the general form of the equation of the ellipse is given. So now we're going to express it in standard form. So what are we going to do? So write the terms with x together and put it inside the parentheses. Do it to the terms with the y also. Now we're going to have 9x squared minus 54x plus 4y squared minus 16y equals negative 61. So 61 was transposed. That's why the sign was changed. Okay, then let's continue. So factor out the greatest common monomial factor of 9x squared minus 54x and 4y squared minus 16y. In 9x squared minus 54x, the greatest common monomial factor, not actually the greatest common monomial factor, but common factor, the common constant factor number is 9. And then in 4y squared minus 16y, so factor out 4, that's why we're going to get that. Now we have 9 times x squared minus 6x plus 4 times y squared minus 4y equals negative 61. What do you think is the next step? We're doing this in our previous topics. Yes, very good, completing the square. So I assume already that you know how to complete a square. That's why we're going to get this. 9 times x squared minus 6x plus 9 plus 4 times y squared minus 4y plus 4 equals negative 61 plus 9 times 9 plus 4 times 4. So in completing the square, so the half of negative 6 is negative 3. Squaring negative 3 is equal to 9. But since we have 9 outside, we're going to multiply it 9 times 9. That's why we have 9 times 9 here in the right side of the equation. Same as in y, the half of negative 4 is negative 2. The square of negative 2 is positive 4. Since 4 is also outside, so 4 times 4 is 16. Or 4 times 4. Just write 4 times 4 there on the right side of the equation. That's why we have those. And let's try to simplify. So since x squared minus 6x plus 9 is already a perfect square trinomial, we can express it as x minus 3 squared. Y squared minus 4y plus 4 is also a perfect square trinomial. Let us express it as y minus 2 squared. That's why we have here 9 times x minus 3 squared plus 4 times y minus 2 squared equals negative 61 plus 81 plus 16. So just continue simplifying the left side, the right side of the equation. So now we have 9 times x minus 3 squared plus 4 times y minus 2 squared equals 36. So for the final touch, divide both sides of the equation by 36 so that we're going to get 1 in the right side of the equation. So that's why we're going to have x minus 3 squared all over 4 plus y minus 2 squared all over 9 equals 1. And this is the standard form of the equation of the ellipse. And from the standard form, we can already determine the value of hk and a and b. So for number 4, based on the ellipse in item number 3, find the following. A, the coordinates of the center, foci, vertices, and co-vertices. B, the lengths of the major axis, minor axis, and latus rectum. And C, the eccentricity. And then lastly, graph the ellipse. Okay. So solution and answers. First, let us find the coordinates of the center. So 3, 2, based on the standard form of the equation. And then the coordinates of the foci. So let us solve for C first. C squared equals A squared minus B squared. So uh, class 3 and 2 are the coordinate of HK, but it's only a coincidence that it is this the value of A is 3 and the value of B is 2. It came from the equation, okay? Then c is x squared equals 9 minus 4. Then c squared is equal to 5. So c is equal to square root of 5. Okay, so the coordinates of the foci are 3, 2 plus square root of 5, and 3, 2 minus square root of 5. Then the coordinate of the vertices. So h, so 3, 5, and 3, negative 1. The coordinates of the co-vertices are h plus or minus bk. So we got 5, 2, and 1, 2. Okay, so check if those are the right coordinates. Then for the length of the major axis 2a equals 2 times 3 equals 6 units. Length of minor axis 2b equals 2 times 2 equals 4 units. For the length of the latus rectum, so LR is equal to 2b squared over a. So just substitute b and a. So we're going to have 2 times 2 squared all over 3 equals 8 over 3 units. For the eccentricity, it is equal to c over a equals c over a. So square root of 5 over 3 approximately equal to 0.7453559992. An irrational number. So lastly, graph the ellipse. So I plotted the center, the two foci, the two vertices, the two co-vertices. So I encoded the general form, the equation of the ellipse. So that is the graph. So if you encode or if you use the standard form of the equation of the ellipse, you're going to get the same graph also. So we're doing a good thing so far. We got the correct answers. So now it's time for practice exercises. I know you're very excited for this. For number 1, discuss the graph of the ellipse. X squared plus 4y squared minus 2x plus 16y equals negative 13. So when you say discuss, you're going to find the coordinates of the different parts of the ellipse, such as the center, the foci, the vertices, the co-vertices, the length of the minor and major axis, the length of the latus rectum, and then the eccentricity as well. Any data about the ellipse. So try to discuss it as much as possible. For number 2, find the standard and general forms of the equation of the ellipse with center at the origin, foci at positive or negative 2, 0, and vertices at positive or negative 3, 0. And also find the lengths of the latus rectum, major axis, and minor axis. So for the eccentricity, then graph the ellipse. Also graph the ellipse in number 1. And then for number 3, find the coordinates of the center, foci, vertices, and co-vertices, lengths of latus rectum, major axis and minor axis, eccentricity, and general form of the equation of the ellipse. The equation is given in standard form, which is x squared over 4 plus y squared over 16 equals 1. And for challenger problems, number 1, find the points of intersection of the ellipse 16 times x minus 2 squared plus 9 times y plus 1 squared equals 144, and the line 4x minus 3y equals 12. Number 2, find the points of the intersection of the ellipse x plus 4 squared plus y minus 3 squared equals 1, and the parabola x minus 2 squared plus y plus 1 all over 3 equals 1. Number 3, find the points of intersection of the two ellipses x squared over 5 plus y squared over 4 equals 1, and x minus 3 squared over 4 plus y plus 1 squared all over 9 equals 1. Then number 4, graph the equations using GeoGebra or symbol of graphing calculator. So if you want, you can find the coordinates and the lengths of the different parts or points in the ellipse. Okay, so that you can have more fun in graphing the equations and figuring out the what will the graph or structure of the ellipse looks like. So class, always remember, do mathematics to learn mathematics. Practice, improve, and stay curious. Keep safe, stay healthy. Thank you for listening. I hope you learned something today. Continue to watch our instructional videos. See you next week. God bless everyone.